I am Mrs.C.GEETHA, Assistant Professor of Computer Science, belongs to A.D.M.COLLEGE for Women. Let's see about the computer networks. Data communication. The term telecommunication means communication at a distance. The word data refers to information presented in whatever form is agreed upon by the parties creating and using the data. Data communication or the exchange of data between the two devices via some form of transmission medium such as a wire cable or wireless. That is delivery, accuracy, timelines and jitter. Components, data representation and data flow can be seen here. There are 5 components of data communication, that is from sender and receiver. By using the transmission media, we can send the data from one protocol to another protocol. Data representation, it can be of text, numbers, integer, audio and video. The data flow can be of 3 types, that is simplex data, half duplex data and full duplex data. The simplex data, that is the data transfer from one direction. In the half duplex, the data transfer by means of time. In the full duplex, data or transmission in both sides of the directions. Network. A network is a set of devices, that is nodes, connected by the communication link. A node can be a computer, printer or any other device capable of sending and or receiving data generated by other nodes on the network. Let's see about the distributed processing, network criteria, physical structure, network models, categories of network and interconnection of network, that is internet, in the below topics. Types of connection. Point-to-point connection, that is a dedicated link is provided between the two devices and its diagram is displayed for your reference. Multi-point. More than 2 specific devices share a single link. That device are displayed here. Physical topology. The topology and its types are displayed. The topology can be of mesh topology, star topology, bus topology, ring topology and a tree. Mesh topology. Every device has a dedicated point-to-point link to every device. Dedicated. Each link carries traffic only between the two devices it connects. A fully connected mesh network has a n and n-1/2 physical channels to link n device. Each device on the network must have a n input or output device. Advantages: less traffic, robust, secure, easy to maintain. It will be also having the disadvantage also, that is need more resource or cable and ports, that is expensive. Star topology. Each device has a dedicated point-to-point link only to a central controller, usually called a hub. No direct traffic and link between two devices. The advantages are less expensive, easy to install and reconfigure, robustness. Disadvantage is single point of failures. Bus topology. The bus topology, in this bus topology, the cable is the backbone for all the device that is connected. A multi-point topology. All the devices are linked through a backbone cable. Nodes are connected to the cable by drop lines and taps. Drop line, a connection running between the device and the main cable. A hub, connected that more than one device by using the main cable. Advantages: base of installation. Disadvantages: difficult reconnection and fault isolation. Ring topology. A ring topology, more than one device are dependent by using the next device. That is, each device is dedicated point-to-point connection only with the two devices on either side of it. A signal is passed along the ring in the direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. Advantages are fault isolation is simplified, relatively easy to install and reconfigure. Disadvantage is unidirectional traffic. Tree topology. Tree topologies integrate multiple topologies together. Example: tree topologies integrate multiple star topologies together into a bus. Advantages: point to point for individual segments. supported for several hardware and software senders. Disadvantages: overall length of each segment are limited by the type of the cabling that is used. More difficult to configure and wire other than the topologies. Okay, a hybrid topologies, and its a diagram are displayed here. By using the hub, the stations are connected together. Categories of network. There are basically four categories of network, that is local area network, that is LAN, wireless area network, that is WLAN, metropolitan area network, that is MAN, wide area network, that is WAN. WAN is switched WAN and a point-to-point WAN are displayed for your reference, that how it works are displayed here for your reference. Interconnection of network, that is internet, are a heterogeneous network made up of 4 WANs and 2 LANs are displayed here. Internet. The internet has changed many aspects of our daily lives. It has affected the way we do business as well as the way we spend our leisure times. The internet is a communication system that has brought a wealth of information to our fingertips and organized it for our use. A brief history of the internet, or that is ARPANET, in 1967 introduced ACM, and 1969 we have introduced SRI, 1972 TCP. The internet today that we are using is ISP. Hierarchical organization of the internet are displayed by using the categories. Protocols and standards. Protocols is a synonyms with rule. Standards are agreed upon the rules. The protocol, standard organization, internet standards will be seen below. Protocols and standards. Protocols. Syntax. Format of the data. Semantics. Meaning of each section. Timing. Then data should be sent and flow fast. And how it is sent it fast. Standard. De facto. By the fact not approved as a standard. Standard organization. International Organization for Standardization, that is ISO. International Telecommunication Union Telecommunication Standard, that is TUT. American National Standard Institute, that is ANSI. Institute of Electrical and Electronics Engineer, IEEE. Electronic Industries Association, that is EIA. Network models, OSI model. Layered task. Network model is a layered architecture, task broken into subtasks, implemented separately in layers in stack. Function need in both the system. Peer layers communicate with each other. Protocol, a set of rules that governs the data communication. It represents an agreement between the communicating device. Task involving in sending a letter. We have one sender and a receiver. By using the hierarchy, the service, the data are transmitted from one end to the another. The OSI model. It is established in the year 1947. The International Standard Organization, ISO, is a multinational body dedicated to worldwide agreement on international standard. An ISO is an open system interconnection model, is the standard that covers all the aspects of network communication from ISO. It was introduced in the late of 1970s. ISO is the organization. OSI is the layered model. Let us see the layered architecture, peer-to-peer architecture and encapsulation. Layered architecture. Layer 1 is physical layer. Layer 2 is data link layer. Layer 3 is network layer. Layer 4 is transport layer. Layer 5 is session layer. Layer 6 is presentation layer. Layer 7 is application layer. Layered architecture, a layered model. In this model, each layer performs a subset of the required communication function. Each layer relies on the next lower layer to perform more primitive functions. Each layer provides service to the next higher layer. Changes in one layer should not require changes in the other layer. The processor on each machine at a given layer are called peer-to-peer process. Peer-to-peer process. Communication must move downward through the layers on the sending device, over the communication channel and upward to the receiving device. Each layer in the sending device adds its own information to the message it receives from the layer just above it and pass the whole package to the layer just below it. At the receiving device, the message is unwrapped layer by layer with each process receiving and removing the data meant for it. The passing of the data and network information down through the layers on the sending device and back up through the layers on the receiving device is made possible by the interface between each pair of the adjacent layers. Interface defines what information and service a layer must provide for the layer above it. The interaction between the layers in the OSI model are displayed here for your reference. Any exchange using the OSI model also displayed, that is the transmission media transmits the data that is displayed here. Layers in the OSI model. Let's see the physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. Physical layer. The physical layer is responsible for movements of individual bits from one hop to the next. Function. Physical characteristics of interface and media, representation of bits, data rate, synchronization of bit, line configuration that is point to point or multi-point, physical topology that is mesh, star, ring or bus. Transmission media that can be of simplex, half duplex or duplex. Physical layer, the data are transmitted from data link layer to the transmission media and the transmission media to the data link layer. The data is transmitted or displayed here. Data link layer. The data link layer is responsible for moving frame from one hop, that is node, to the next. The function is framing, physical addressing, flow control, error control and the access control. Data link layer. From network layer to the physical layer, the data are transmitted and the data are retransmitted from a physical layer to network layer. Hop to hop delivery are displayed here. For the hop to hop delivery, we use the physical layer, data link layer and the days on how the data are transmitted by using the intermediate system. In this example, the two nodes are connected by a link. At the data link level, the stream contains physical address in the header. These are only the address needed. The rest of the header contains the other information needed at this level. The trailer usually contains the extra bits needed for the error detection. Network layer. The network layer is responsible for the delivery of individual packets from the source host to the destination host. Source to destination delivery, responsible from the delivery of packets from the original source to the final destination. The functions are logical addressing and routing. The network layer, from transport layer, the data are transmitted to the data link layer and from data link layer, the data is transmitted to the transport layer. Source to the destination delivery are displayed by using this transport layer. Transport layer is responsible for the delivery of a message from one process to another. Process to process delivery. The functionings are port addressing, segmentation and reassembly, connection control that is connection oriented or connectionless, flow control and error control. Transport layer, segmentation and reassembly. In this we use the transport layer to network layer, and from network layer it moves on by using the transport layer, it moves on to the session layer. A reliable process to process delivery of a message is displayed here. Session layer. The session layer is responsible for dialogue control and synchronization. Is establish, maintain and synchronize the interaction between the communicating system. The function or dialogue control, synchronization and checkpoints. Session layer. A synchronization from presentation layer to transport layer, it is synchronized, and from transport layer to the presentation layer. Presentation layer is responsible for the translation, compression and the encryption, concerned with the syntax and semantics of the information exchange between two systems. Functions are a translation, encryption and decryption and compression. The presentation layer, from application layer, the data is transmitted to the session layer, and from session layer it transmits the data to the application layer. Application layer. The application layer is responsible for providing service to the user. The function can be of nurture, network, virtual terminal, that is remote login, file transfer and access, mail service, directory service, that is distributed database, accessing the World Wide Web. Application layer. The diagram is displayed for your reference. Summary of the layers are displayed here. from a physical, data link, network, transport, session, presentation and application layer. The OSI model and its layer, how the data are used or displayed here for your reference. Okay, let's see about the TCP/IP protocols. TCP is the transmission control protocol and the internet is the IP is the internet protocol. The layers in the TCP/IP protocol suite do not exactly match those in the OSI model. The original TCP/IP protocol suite were defined as having 4 layers, that is host to network, internet, transport and application. However, when TCP is compared to OSI, we can say that the TCP protocol suite is made of 5 layers, that is physical, data link, network, transport and application layer. Let's see the topics of the physical and data link layers, network layer, transport layer and application layer. The TCP and OSI model, its diagram is displayed, that is OSI model and the TCP/IP model is displayed here for a reference. Internet layer. The TCP/IP supported the internet protocol and reliable. IP is a host-to-host protocol. The supporting protocols are address resolution protocol, that is ARP, reverse address resolution protocols, that is RARP, internet control message protocol, that is ICMP, internet group message protocol, that is IGMP. Transport protocol. It is the process to process protocol. It defines the UDP, that is the user datagram protocol. TCP, that is the transmission control protocol. Stream control transmission protocol, that is SCTP. Addressing. 4-level addresses are used in the internet employing the TCP/IP protocols, that is the physical, logical, port and specific. That is the physical address, logical address, port address and specific address will be displayed below. The addresses in the TCP/IP, the diagram is displayed for your reference. The relationship of layers on address in the TCP/IP are displayed here. Physical address or imprinted on the NIC, most local area network, that is the internet, use a 48-bit, that is 6-byte physical address written as 12 hexadecimal digit. Every byte is separated by a colon. As 6-byte data, that is 12 hexadecimal digits physical addresses are displayed here. A physical address, also known as the MAC address, is the address of the node as defined by the LAN or WAN. It is included in the frame used by the data link layer. The physical address in the datagram may change from hop to hop. Logical address. IP address are necessary for universal communications that are independent of physical network. No two host address on the internet can have the same IP address. IP addresses in the internet are 32-bit address that uniquely define a host. The physical address will change from hop to hop, but the logical address usually remain the same. Port address. Port address is a 16-bit address represented by one decimal number ranged to choose a process among the multiple processes on the destination host. Destination port number is needed for delivery. Source port number is needed for receiving a reply as an acknowledgement. And a TCP/IP, in TCP/IP and 16-bit port address represented as one single number. The port address and how it works is displayed here. Specific address, email address, universal research locator, that is the URL, the domain name system, that is DNS, translate human-friendly computer host name into the port address. For example, www.example.com is transferred to 208.77.188.166. Thank you.